Good job. Here we go.
Alright. Sphere A with the charge
Can't hear you. You can't hear me.
Alright. Sphere A with a charge of 6.0 is located near another charge sphere. Sphere B has a charge of negative 3.0 and is located 4.0 centimeters to the right of A.
Alright, stop right. Let's start out what you just read, right? This is the first sphere. It has a charge of what? What's the charge?
6.0.
See? So this represents the charge, QA. 6.0 mu. What's mu? What does mu represent? It's called micro. 10 to the negative 6. That's what it means, okay? So that's 6.0. And the next one is what? Next one is negative. We're going to call it B. And QB. How much is QB? Negative 3. What else?
Okay, 4.0
4.0, so the distance between them, right there, let's call it RAB. That's the distance between A and B. And it's 4.0 centimeter. We need to convert that to meter. 0.04 meter. Okay? Or, better yet, let's write it this way. 4.0 times 10 to the negative 2 meter. I prefer it that way. And you'll see why later on. Okay?
Right.
What else? Read.
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 A, what is the force of sphere B on sphere A?
What is the force of B on A? So we need the force from this on that. What kind of force will it be? Attractive or repulsive? And it's on this, right?
Yes.
So I'm going to, since it's on this, I will draw the force on this charge. Which way should it point?
That way. Towards it.
There it is. And we're going to call it force of B on A. It's force of B on A. So now down here, we're going to calculate this force. F B A. Okay? So, what's our strategy? What's our strategy? Our strategy is to use Coulomb law. So our equation for Coulomb's law,
Equals to K.
F of B on A is equals to K. That's a constant.
Q1,
QA,
QA, QB,
QB,
over R, A.
RAB squared. We're applying that to this situation, okay? So now let's calculate. FBA is equal to K. The value of K is 9.0 times 10 to the 9 Newton meter square Coulomb square. That's the value of k right there. It never changes. It's always that. The value of QA is right there. 6.0 times 10 to the negative 6. That's QA. And QB is 3.0 times 10 to the negative 6. Now, I didn't put the negative sign. Don't worry about the negative sign. The negative sign just tells us about the direction of the force, okay? Don't worry about it right now. And that's divided by r squared, 4.0 times 10 to the negative 2 meter squared. Now, you can put this in your calculator and crank it out real fast, and you'll get an answer. But I'm going to show you how to do it if you don't have a calculator, okay? So, the way to do it is, first step, you take all the numbers. Those are your three numbers at the top. 9.0 times 6.0 times 3.0. Those are my numbers. Multiplied by my total exponent. Now, since I'm multiplying, I have to add all three. Here I have a 9. 9 minus 6 minus 6, negative 3, right?
Yeah.
For my units, I have n, m squared, okay? And I have c squared at the bottom, but look over here. C times c is what? C squared divided by c squared, they cancel. That's the top. Now let's square the bottom. 4.0 times 10 to the negative 2 meter times 4.0 times 10 to the negative 2 meter. What is that going to give us? 4 times 4
16.
times 10 to the
-4.
meter squared. So I have 16 times 10 to the negative 4 meter squared. Meter squared cancels meter squared. So all I'm left with so far is n. Alright? So now what I'm going to do, I'm going to take all the coefficients, put them together, and take all the exponents and put them together and crank out our answer. So 9 times 6, 54 times 3, 162 divided by 16. That takes care of my numbers. Times, at the top, I have 10 to the negative 3. And at the bottom, I have 10 to the negative 4. And over here is my n, which is the unit for force. So now 16